Hello dear students, welcome to EPG Pathshala. I am Dr. DC Saxena, Professor and Head of the Department of Food Engineering and Technology at Sant Longowal Institute of Engineering and Technology, Longowal. I am presenting you the paper Technology of Meat, Poultry, Fish and Seafood Products. Under these products, the egg, as you know, it is having a very strong shell and it cannot be seen just outside of the shell. So, we have to know the internal quality of egg, which are useful for its preservation, and these aspects will be explained to you by my co-author Ms. Kulsum Jan.
Hello students, welcome to EPG Pathshala. I am Kulsum Jan from Sant Longowal Institute of Engineering and Technology. Today, I am going to talk about module number 25, that's internal quality of egg and its preservation, of paper number 8, technology of meat, poultry, fish and seafood products. In this module, we will learn about the quality which is defined as the properties of any given food that have an influence on the acceptance or rejection of this food by the consumer. Egg quality is a general term which refers to several standards which is defined both in terms of internal and external quality. External quality is focused on shell, cleanliness, texture, shape, whereas internal quality refers to egg white, that is albumin, cleanliness and viscosity, size of the air cell, yolk shape and yolk strength. Quality of the egg has been classified as internal and external quality. Internal egg quality involves functional, aesthetic, and microbial properties of the egg yolk and albumin. The proportions of components for fresh egg are 32% yolk, 58% albumin, and 10% eggshell. Egg yolk from a newly laid egg is round and firm. As the egg gets older, the yolk absorbs water from the egg white, increasing its size. This produces an enlargement and weakness in the vitelline membrane. The yolk looks flat and shows spots in it. As soon as the egg is laid, its internal quality starts to decrease. The longer the storage time, the more the internal quality deteriorates. However, the chemical composition of the egg, that is yolk and the white, does not change much. The decrease in the internal egg quality once the egg is laid is due to the loss of water and carbon dioxide. In consequence, the egg pH is altered, resulting in watery albumin due to the loss of the thin albumin protein structure. The cloudy appearance of the albumin is also due to the carbon dioxide. When the egg ages, the carbon dioxide loss causes the albumin to become transparent compared with fresh eggs. The next one is the external quality, which includes to maintain the consistently good shell quality throughout the life of the hen. It's necessary to implement a total quality management program throughout the egg production cycle. It has been always recognized that the hen has most extraordinary method of obtaining the deposited calcium in the entire animal kingdom. An egg has an average of 2.3 gram of calcium in the shell and almost 25 mg in the yolk. External egg quality is judged on the basis of the texture, color, shape, soundness, and cleanliness. This is according to the USDA 2000 standards. The shell of each egg should be smooth, clean, and free of cracks. The eggs should be uniform in color, size, and shape. There are 5 major types of the shells problems in the egg industry. Number first, the cracks due to excess pressure. Number second, cracks due to thin shell. Number third, body checks. That is number 4, pimples or toe holes. And the last one is the shell-less egg. Quality may be defined as the inherent property of a product that determines its degree of excellence. Those conditions and the characteristics that consumers want and are willing to pay for are, in a broad sense, factors of quality. The quality of an egg is determined by comparing a number of the factors. The relative merit of one factor alone may be determine the quality source of the egg. In as much as the final quality score can be no higher than lowest score given to any of the quality factors. Quality factors for eggs may be divided into general groups, exterior and interior. Immediately after the egg is laid, the internal content and structure begin to change. This is a continual, irreversible process, and even the most carefully controlled storage conditions can do no more than slow down the rate of deterioration. The main changes which occur are outlined. As far as the internal quality is concerned, it involves the contents of the egg as they appear before a candling light, or when the eggs are broken out and measured by the Hog unit method plus visual examination of the yolk. Even under the most favorable conditions, egg quality is relatively unstable as the interior quality of the egg deteriorates from the time it is laid until it is consumed. Sometimes quality changes render eggs useless for food before they reach consumers. However, when eggs are properly cared for, the quality decline can be minimized. When the egg is laid, it's warmer than its surroundings. As it cools, the contents contact and a small air space is formed between the inner and the outer shell membrane. The air space normally, but not always, forms at the broader end of the egg because there are more pores in the part of the shell. As the egg aids moisture and the carbon dioxide to be lost through the pores. Air moves in and the air space increases in size at a rate which is determined by the temperature and the relative humidity of the surrounding air. The warmer and the drier the air, the quicker the moisture lost from the egg. The size, maybe height, of the airspace is used as an appropriate guide to the quality and age of an egg. The air cell is the easiest quality factor to evaluate as it can be judged objectively by a simple measuring device, the air cell gauge. In candling, the air cell is considered a relatively unimportant quality factor for determining internal quality when compared to the broken out appearance of an egg. However, the air cell is one of the factors of the US standards and therefore it can be determining factor in classifying the individual egg in terms of quality. Depth is the only quality factor considered with the air cell. Movement is not considered a quality factor, and the air cell may be shown unlimited movement and be free or bubbly in all qualities. Here are some of the descriptive terms used for air cell. Depth of the air cell is the airspace between shell membranes, normally in the large end of the egg. The depth of the air cell is the distance from its top to its bottom when the egg is held air cell upwards. Free air cell. An air cell that moves freely towards the uppermost part in the egg as the egg is rotated slowly. Number second, bubbly air cell. A ruptured air cell resulting in one or more small, separate air bubbles usually floating beneath the main air cell. It has been seen in a very fresh, good quality egg, the albumin is jelly-like and may have a cloudy appearance. As the egg ages and the carbon dioxide is lost through the shell, the contents become more alkaline, and this causes the albumin to become transparent and increasingly watery. At the higher temperatures, the rate of carbon dioxide loss is higher and visible signs of aging occur quicker. The quality of the albumin can be assessed by measuring the height in millimeters of the outer thick albumin. The height of the albumin and the weight of the intact egg is used to calculate the Yolk unit value. It is the protein in the thick albumin which begin to break down during storage as the egg becomes more alkaline. At the same time, water slowly migrates into the yolk and the shell from the albumin so that both may develop a mottled appearance and the yolk becomes enlarged and flattened on breakout. The yolk moves away from the center of the egg and may eventually rest against the shell itself. This breakdown of the albumin makes the egg extremely vulnerable to microbial invasion. Eggs and food, like all foods, they must be assessed for quality to ensure that they are acceptable to consumer. Failure to remove defective eggs can lead to complaints, losses of the business, and prosecution. Every day, over 26 million eggs are produced in India or in other countries like UK. Successful quality control requires a combination of skill, concentration, and practice. Gradually, automatic and mechanical developments have emerged which have reduced reliance on the human eye. The appearance of the yolk as the egg is twilled is candling, is one of the best indicators of the interior quality of shell eggs. The characteristics of the yolk are determined by the shadow that it casts upon the shell before the candling light. The appearance of the yolk is dependent on the condition of the white. As the egg ages, the rate of the carbon dioxide and the moisture loss in the white increases and affects the condition of the white. However, there are three factors about the yolk itself that are considered in judging egg quality by the yolk: distinctness of the yolk shadow, outline, size, shape, and yolk, if defects and germ development. Here are some of the quality parameters used to determine the freshness of the egg. The thickness and the consistency of the white. The thicker the white, the less distinct the outline appears, because the yolk is prevented from moving close to the shell. Condition of the yolk. The condition is determined by the presence or absence of blemishes that show up before the candling light as dark shadows on the yolk, or the presence of the absence of an off-colored yolk appearance, which shows as a grayish or greenish shadow. Color of the yolk is used or it is difficult to determine the color of the yolk before the candling light except of color. However, extremes in yolk color may influence the candler's judgment of the egg quality. An extremely deep color yolk under some conditions would cast a darker shadow before the candling light that would a lighter color. The yolk in a freshly laid egg is round and firm. As the yolk ages, the strength of the yolk membrane weakens, allowing water to absorb from the white. The increase in its size and weight and causes it to stretch and weaken the vitelline membrane and to assume a somewhat flattened shape on top and an out of round shape generally, resembling a balloon partially filled with water. Yolk size and shape are mentioned only in the lowest quality classification for eggs, that is P quality, whereas these factors become apparent. Many factors affect egg quality. Sometimes the cause is not a single factor, but a combination of factors. A few of these problems can be prevented or reduced by good hen management. Producers should remember that genetics, feed quality, environment play a role in egg quality. The most reliable factor is age. A young pullet producer, small eggs with strong eggshell and albumin that stands high. As the hen ages, the shell thin and the albumin begins to weaken and run. Hence, can be molded to induce another egg cycle, which will improve egg quality, or this may lead to replace with young pullets. Internal egg quality faults and abnormalities. Doubled yolked egg. In a young, highly productive laying hen, two yolk evolutions may take place almost at the same time. When this happens, the two yolks progress as one down the oviduct in the just a position and they enter the shell gland together. Number second, blood spots in eggs. They are normally found in or around the yolk. They can be caused by one of the tiny blood vessels in the ovary breaking at the time when the yolk is released. High levels of the activity or disturbance, particularly at the time of ovulation, are likely to increase the incidence of these. Eggs from free-range laying hens may have some protection from blood spots due to rutin, a substance in the grass which may have some effect in stopping bleeding. Meat spots in egg are usually brown in color and associated with the albumin rather than yolk. They often consist of small pieces of body tissue, such as the internal wall of the oviduct. Their incidences varies according to the bird age and health, and also due to strain differences. In blood-shelled eggs, they are more difficult to identify without breaking the shell, and there is also evidences that brown laying hens are more likely to produce them than white hens. The next one is the watery whites. The internal quality of freshly laid eggs deteriorates with increasing flock age and some eggs from older birds may have unacceptability watery whites even when laid. Viral disease such as infectious bronchitis can also affect the ability of the bird to produce thick albumin. Abnormal yolk color. The color of the yolk is determined by the diet of the bird, although some disease conditions can also contribute. Green yolks can be caused by the birds consuming green herbage to excess. The color can vary from olive to khaki, but may only affect a proportion of the birds within a flock. The fault occurs most frequently in the spring when herbage is most lush and where birds take a higher proportion of their feed from the range. Mobile and bubbly air spaces is the next. Although the air space usually forms at the broader end of the egg, it can occasionally be found where there is a shell structure fault or abnormality. In other cases, a bubbly airspace may be seen within the albumin, and this is usually caused by a ruptured inner membrane. Bacterial and fungal contamination. The bacterial and molds may naturally be present on the surface of the egg shell. In certain circumstances, some of these can pass through the shell and multiply within the egg, typically producing black, red, or green rods. If such eggs are examined using a candling lamp, they will appear as dark, irregular patches. Standards of yolk quality. The term used to define the 3 degrees of distinctness of yolk shadow outline in the US standards of quality for shell eggs are: outline slightly defined, a yolk outline that is indistinctly indicated and appears to blend into the surrounding white as the egg is twirled, that is being considered under AA quality. Quality line fairly well defined. A yolk outline that is discernible but not clearly outlined as the egg is twirled, that is considered under A quality. Outline plainly visible. A yolk outline that is clearly visible as a dark shadow when the egg is twirled, that is B quality. Egg white influences the weight of the components of eggs, especially egg albumin and yolk. The eggshell quality is given through the weight and the percentage of shell, thickness, and the strength. The differences in the eggshell quality depend on the environmental conditions and the feed quality and also of strain of layers. The egg white is characteristic which directly affects eggshell thickness and egg size also. Brown egg layers produce high shell weight in comparison with some other hybrids of white color, but the eggshell deformation in brown eggs is usually higher. Significant negative correlation on eggshell deformation and the strength as well as the thickness is found in brown eggs. External egg quality faults. Misshaped eggs. If albumin quality is very poor, there is no sound foundation upon which to build the true shell. The result can be distinct to crinkled shell typical of certain viral disease. Misshaped egg can also arise from the other reasons. For instance, the shell may break in the shell gland during the formation process. The damage can be partly repaired by a bulge forms around the center of the egg, an equatorial bulge. Any factor which causes disturbance to the birds 10 to 14 hours before the egg is laid is likely to increase the incidence of this fault. Coated shells. Additional calcium may be deposited on some eggs, causing calcium splashing or a pink or lilac colored egg. Typically, these faults are caused by the egg remaining in the shell gland for an extended period. Often, young flocs just coming into production are very susceptible to this, and any stresses or disturbances at the time when the egg is due to be laid will encourage the bird to retrain the egg. Rough-shelled eggs. In some cases, 2 eggs may be in the shell gland at the same time, and this causes a form of rough-shelled egg, often referred to as a target or thumbprint. This problem can also result in slab-sided eggs. There are other types of the rough-shelled eggs, including those with pimples or a sandpaper type texture. But health and age often affect the incidence of this. The next one is the pale-shelled eggs. Some of the eggs shell laid by brown laying hens may be very pale or white in color. The effect is purely cosmetic, but such eggs may be rejected by certain customers. Older laying hens and disease conditions tend to increase the incidence of pale shells. This is also some evidence that pale-shelled eggs are more common in free-range flocks. Soft and weak-shelled eggs. Soft and weak-shelled eggs can be common in older birds, especially those which are nearing the end of the laying period, having produced a high-quality output of eggs. Where they are seen in younger flocks, they can be associated with coated or rough shells. If an egg is retained in the shell gland for too long, the next evolution takes place at the usual time. But before the previous egg is laid, the second egg may spend less time than normal in the shell gland, and the result is soft or shell-less egg. In such cases, a hen may not lay an egg on one day but may lay both a coated and a soft-shelled egg. Temporary thinning of the eggshell may occur during periods of high temperature, that is above 25 degrees centigrade. Since feed intake is reduced, the shell quickly regains normal thickness when temperatures are reduced and feed intake increases. Cracked eggs. Eggshell can easily be damaged after the egg is laid, and cracking is one of the most common reasons for downgrading. It may be due to either to an inadequate eggshell being laid or to poor handling, which may occur during collection, grading, or transportation. Different characteristics of fresh, high-quality eggs. Yolk is high and firm above the white. Number second, small yolk diameter. Number third, yolk is centered in white. Number four, high ratio of thick to thin white. Number five, high standing thick white. Preservation of egg. Eggshell quality and egg internal quality are of major importance to the egg industry worldwide. For the egg industry worldwide, the production of eggs which are of good eggshell quality and good internal quality is critical to the economical viability of the industry. Eggs for processing should be visibly clean prior to breaking and separating. Cracked eggs may be processed. Broken eggs should be processed and should be disposed of in a safer manner. Dirty eggs should be disposed of in a safer manner or may be cleaned. Separating of egg contents from the shell should be done in a manner that will, as far as possible, avoid cross-contamination between the shell and egg contents. Avoid contamination by personnel or from equipment, and that permits examination of egg contents. Eggs deteriorate rapidly during storage under ambient conditions. The reason for this rapid spoilage is that the porous shell of the egg allows escape of carbon dioxide and moisture, resulting in the loss of the weight. Coating of the shell eggs with the white paraffin based mineral oil containing antifungal and bacteriostatic agents have been found to aid in maintaining the quality. A technique is available to preserve the shell eggs by washing and coating using egg washing powder and egg containing oil, for which formulations have been developed at CFTRI, Mysore. The egg washing powder has a combined detergent and sanitizing action. It lowers bacterial load, increases shelf life, sale value, and consumer acceptability. The egg coating oil formulation preserve the shell eggs for about 4 weeks at 25 degrees centigrade to 30 degrees centigrade and 10 days at 38 degrees centigrade. Eggs keep well for 24 weeks at 7 degrees centigrade and for 12 weeks at 13 degrees centigrade. Eggshell quality and egg internal quality are of major importance to the egg industry worldwide. For the egg industry worldwide, the production of the egg, which are of good eggshell quality and good internal quality, is critical to the economic viability of the industry. Eggs for processing should be visibly clean prior to breaking and separating. Cracked eggs may be processed. Broken eggs should not be processed and should be disposed of in a safer manner. Dirty eggs should be disposed of in a safe manner, may be cleaned. Separating of egg contents from the shell should be done in a manner that will be as far as possible to avoid cross-contamination between the shell and the egg contents by personnel from equipment, and that permits examination of egg contents. So, students, let's now recapitulate what we have learned about the emphasis on the internal and external quality of egg and other procedures to minimize the quality loss of the eggs. To minimize the egg quality problems, two things are very important. That is, frequent egg collection, mainly in the hot months, and rapid storage in the cool room. The best results are obtained at a temperature of 10 degrees centigrade. These are 6 main factors affecting internal egg quality: disease, egg age, temperature, humidity, handling, and storage. Moreover, it's important for egg producers and marketers to realize the factors which contribute to eggshell and egg internal quality. Knowing what causes a reduction in eggshell and interior quality, which is very important. But equally important is knowing how to correct the cause to conserve good quality eggs. The quality of the eggs and their stability during storage are largely determined by the physical structure and the chemical composition. It's important, therefore, that those concerned with the handling of the eggs are knowledgeable about this information in order to understand why eggs need to be treated in a specific way and to have a rational basis for the day-to-day marketing decisions. So maintaining the fresh egg quality from producer to the consumer is one of the major problems facing by those engaged in the marketing eggs. So proper attention to the production, distribution, and point of scale phases are of the vital importance in maintaining egg quality. The main production factors that affect the quality maintenance are: number first, breed, age, feed, management, disease control, handling collecting eggs, and the housing of the eggs.
By now, you know how to check the internal quality of eggs and its different preservation methods, which has been explained by my co-author. Now, we have to know about the technology of different egg products like whole egg powder and egg yolk powder, which are very important